The first law of thermodynamics states that energy cannot be created nor destroyed. So the energy in a system in an isolated system is conserved. In this experiment, we aim to prove this by using a blow dryer and take experimental measurements and compare to their theoretical values.
So we have here our system. It's a hair dryer, and we assume that it's a steady system because we don't see any change over time. And we have an open system also because we have our fixed boundaries where mass come in and mass come out. And we give an electric word so we can hit the air, and thus we have a Q out.
The data was obtained by different methods. We used special thermometers and a device called anemometer. For the temperature of the inlet, which actually was room temperature, we used the special thermometer. And for the velocity of the outlet and the temperature of the outlet, we used the device called anemometer.
After we get our data, we started by getting the mass flow rate. For this, we use the density of air at 60 degrees and 46% relative humidity times our velocity and the area of the circle. Then for Q out, we had to get first the area. So we got the area of the sphere times 3/4 because it was the part that was contacted by the heat, and we also had the full area of the cylinder. Then we made the addition and get the full area, and we put it in the Q out equation. And there we have the convection coefficient, the total area, and the difference of temperature. And for the enthalpy, we use the method we saw in class, and we use it for both enthalpies.
Doing the first law analysis for the system. First of all, we don't have Q in, but we do have Q out. There's electrical work entering the system. But there's no work out. In the internal energy part, we will divide it in enthalpies and velocities. Actually, we're neglecting velocities since the quantity of energy they give to the system is very low. Then we will end with this final equation. After obtaining all the data and the calculations, we took out of the equation whatever was not in the system. We actually neglected velocities in the internal energy calculation, but we used velocity 2 in order to obtain the mass flow rate. At the end, we calculated our electric work.
So the theoretical value that we obtained for the electrical work was 1,124.76 watts. And we calculated the relative error using the reference, the label the hairdryer had, and we obtained as a result 30.78% of error. However, we decided to also take into account the efficiency of our device, and we took it as 80% efficiency, and this reduced the error to 15%. We believe that the source of the errors that we obtain are that mainly because we didn't measure properly, maybe. There are some human errors in the measurements. And also there are other factors like peaks in the voltage that we can't control. Also parts of the device that were heating and maybe we didn't take into account.
Once the experiment was performed, we can prove that the first law of thermodynamics was fulfilled. In this case, we used the electrical work to prove the law because the theoretical value was of 1,625 watts and the experimental value was of 1,124.76 watts. And in this case, we proved the first law of thermodynamics because the value was approximated, and this is an example of the conservation of energy. In this experiment, we realized that obtaining the values that we usually find in the cross problems is not an easy task.